I don't think people really understand that you're going to have to go outside the comfort zone of a unified software hardware stack offered by a particular vendor, as you always have, in order to get the value that you're looking for, or the economy that you're looking for in the solution that you're building for yourself. IBM has always had top to bottom solutions. They're very good at building them. They also cost a fortune. Okay?
I understand.
We also always had high availability clustering from specific vendors that specialized in that, but the solutions were extremely expensive until you had Beowulf and Linux, right?
Right.
Or until Microsoft added clustered services to its generic operating system for free. Okay, so you end up with the change a little bit that is enabling some of the rollout of this and making it a little more cost efficient without going to highly proprietary homogeneous structures. Okay. You are enabling that at the storage layer, but you're also kind of enabling it at a hyper-converged layer as well, because you work with Hyper-V. Mm-hmm. You work, I believe you work as a VM inside VMware, right?
Sure.
Yeah, you don't really care what the operating system or hypervisor is, right? So, again, the only thing that I'm wondering is, your old model, which I love very much, was I'm going to create a generic pool of storage resource with a hypervisor, with a layer over the top with software controls on it, okay? And I'm going to be able to expose portions of that pool to whatever operating system or application requires it, okay? That was the fundamental approach. And
that is the fundamental approach.
The issue that other people were bringing up about storage did not apply to you because you weren't hardware. They said, when we move an application, vMotion it from one server to another, we have to interact with that application and change all the locus so that it can find its way back to its storage share on some hardware.
Virtual disk is a virtual disk.
Exactly right. And when you start creating a pool, and you've got a virtual set of LUNs that are basically traveling with the application, you don't have to reorganize or reconstitute it. That seems to have already been the solution that they're trying to solve with virtual SANs. Do you understand?
No, I don't. I don't see virtual SANs as trying to solve that problem.
Well, they're trying to actually just give the hypervisor vendor more control over
They're trying to give the hypervisor vendor more control. They're trying to do one thing that's positive, and that is that they're trying to reduce the cost of entry for very small SANs. That's a good idea, right? So, but for us, vSAN is not that. For us, a vSAN is a capability. Again, first of all, there is no product in DataCore called a vSAN. Right. For DataCore, vSAN is currently a architecture for implementing a SAN without a series of one or two or three DataCore centralized nodes at the core of the storage area network. What that means is that the SAN is created in 2 cooperating servers or 5 cooperating servers that are themselves application servers, or in a single one, and it becomes our hyperconverged solution. So we have a number of partners that use us for hyperconvergence. We are the software hyperconvergence within the platform. Now, what's the advantage of using DataCore for that purpose? What's the advantage of using DataCore for cooperating servers that lack a storage core? Truth is that it's the same as the one we just discussed, and that is, from the minute that runs, you are not talking about federated, you are federated. Right.